Hi everyone, welcome to session 3. Today we're going to cover data transformation. So that's going to include learning 2 ways of making dummy variables, as well as how to create a variable based on another variable that we already have in our data set. So let's get to it. Alright, so what I've done here is I've gone ahead and run our first few lines of code. And I've also loaded our CCES data set. We're using this again, and as you guys remember, it's a relatively large data set that takes a while to load. So I've done that for us, and I've also loaded 3 packages that we're going to need today. I've got reads data 13, I have ggplot2, which we'll need for graphics, and then Dippler. I'm not sure if that's how you say it, but that's how I say it. So today what we're going to be talking about first is looking at recoding variables that already exist within our data set but just need to be transformed in some way. So we'll look first at binary variables that already exist in sort of a binary fashion, so 0, 1, and then variables that are not already binary but need to be collapsed down to a 0, 1 variable. So let's go ahead and get started. So first, let's start with a variable that's already binary, which of course we're going to use gender because that's what we always use. And so first thing, if you guys will remember, what I always like to do is I always like to make a copy of, go ahead and run this. I always like to make a copy of whichever variable I'm going to be manipulating so that the original variable, if I do something crazy, I've left the original variable alone in my data frame and I don't have to go back and try to figure out how to fix it. So I strongly take it from somebody who's made this mistake before, strongly encourage you guys to do that. So I copied over the variable, and I've used head, our head command, which we've spoken about previously, just to double check and make sure that it looks like it copied over correctly. And you can see down here in the console that it looks like it did. So we're good to go. Now, again, you guys should recognize these next few lines of code, since these are things that these are lines of code that we've used before. So again, what we're, as a refresher, what we're doing is we're going in this first line where it says levels, that's going in and that's giving a numeric value to each possible level of this factor variable, so 0, 1, 2, and 2. And we'll talk more about why I'm giving the same value to 2 possible response categories in a second. And then the second line actually converts those values to their numeric values that I've assigned them in the previous line. And then we can use, all right, so this is actually a really good, good example of what can go on. We have a warning message that NAs have been introduced by coercion. So let's stop and see what's going on here. All right, so I dug around in our data a little bit, and what it looks like is that the head command did me wrong originally when I ran it, and there was a problem with the way that the variable copied over. So I saved you guys a few minutes of time of watching me try to figure that out, but just know that this is something that we regularly have to do. We get a warning message and we have to figure out what's going on. So I've got it fixed, and what I did was I just went and recopied the variable, because what I was doing was I had copied over just an entire data frame full of observations of NA, which obviously is not what we wanted. So I just went back and I changed a small part of the syntax. Instead of doing using an equal sign, I used the kind of reverse arrow is what I think of it as. So I did that, and that actually worked. And then I reran head to and actually I just ran the entire variable, and so I could see several lines of observations, as you guys can see here, because I wanted to make sure after getting burned, I wanted to make sure that it actually gotten copied over, and it looks like it did. And so then I went back and went through those lines of code that we already talked about and ran my table command, and this actually created the dummy variable that we wanted. So we are good to go there. Now that we had that little bit of a, I won't say a mix-up, but I think that was a good learning opportunity for all of us. So now we're ready to move on and look at how to make a dummy variable for a variable that doesn't have a clear necessarily cut point. It isn't already binary. So what we're going to do, again, we're going to use another variable that we're familiar with. It's the education variable. So again, I'm going to copy. And here I've used the table command to make sure that it copied over correctly, and the table command looks like it did. So if you'll remember, that's where we saw our NA problem last time. So I have confidence in this. We've got our copy. All right, I'm going to change this. I've been burned by that head command now, so I want to change that. Run all of those lines of code again, assigning a numeric value to each level, and then actually converting those levels that had previously been characters into their numeric values. All right, and perfect. So what we can see here is that it looks like everything worked as planned. So now what we need to do is think about what makes sense as a cut point. If we're creating a binary variable from a variable that has multiple levels and maybe not a clear dividing line the way that gender does, let's think about what makes sense for our research question. So if I'm interested in the way that a college education affects your political preferences, then what I might want to do is create a variable that would have all college graduates in one category and all non-college graduates in another. Now again, think about your research question and think about your theoretical argument. If your argument is that attending college itself is what causes people to have different levels or different kinds of political preferences that may be of interest to you, then maybe actually coding everything as coding college graduates as our cutoff doesn't make sense. Maybe we want to look at everybody who's attended college, so maybe we want to include our 2-year college graduates in that case. Maybe we want to include the respondents that have just some college. So again, just take this opportunity to remind you guys to really think through what these cut points mean and to use them in a way that will make sense for your research question. So what I've done is I've chosen the cut point of 5 and above. So that is everybody that's actually graduated from a 4-year institution, as well as the postgrad. And since I've already done that part, I'm not going to run this line of code again. Apologize. My error. Next line of code that I need to run is actually converting these numeric values into the dummy variable. All right. Perfect. So I ran the table command again, and that looks good. Now, what's the problem here? Well, the problem with this variable that I've done is that we don't actually have, we didn't actually create the variable inside of the data frame. And that can be a problem when we go back and we want to use these variables in our analysis. So let's go back and just do this. And we'll run it down here. Actually, let's do this. Just double check. All right, perfect. Now that we've looked at how to make a dummy variable, how to transform variables that already exist in our data set, let's take a look at how we can actually create new variables inside of that same data set. So the first thing we're going to look at is how to create an age variable in the CCAS based on a different variable that already exists in there. So in the CCAS data set, what we have is birth year, but we don't have actual age. So we can create a rough estimate, be good enough for us, as to what these respondents' age are by simply, we can simply subtract the birth year from 2019. And you can see there we've got our table, and now we've got all of our correct ages, and we can see how many respondents fall into each one of those years. So that's perfect. The only thing to remember here is that the operator that I've used, like I said, I've just subtracted the birth year minus 2019. That only has meaning for numeric values. So for some reason, this birth year variable was coded as a factor, that operator, that minus operator, wouldn't work. So just keep those things in mind. If you run into errors, go back and check and see what kind of variable you're working with. All right, so now let's, we've again used something that we already had to create a new variable. Let's look at creating really from scratch. So let's say we had data on the first age that somebody voted. That might be of interest to us if we're interested in how voting patterns persist over time, or whatever you may be interested in. So what we can do here is we can use our norm to create, we need enough of these fake ages for each one of our observations, and I've set the average age the first time somebody vote at 30, and with a standard deviation of 2 years. So let's go ahead and run that. Perfect. And let's check out the distribution. So first thing that we can use is the table command, but this isn't really that helpful. So if we want to see the actual distribution, we can use our histogram, which you guys can see there, or we can use our box plot command. Now, box plots are really helpful if you're looking for outliers. As you can see, those dots on our edges, those are what we would consider outliers. Whether or not those outliers are a concern is going to depend on the distribution and on what we're focused on. So we'll come back and talk more about outliers in a moment, but just for the time being, know that there are many ways to create the